Okay, well, just when you thought you were done with exponents, we're not. We learned all those exponent rules in 6.1. We know when we're multiplying with the same base, we add the exponents. When we're dividing with the same base, we subtract the exponents. We learned when we raise an exponent to an exponent with the parenthesis, we multiply them. We also learned about negative exponents. So on here, we could see we learned this, right? X to the negative 1 is equal to 1 over x. So the question of the day is, what does this mean when we have a fractional exponent? Well, fractional exponents are roots. And remember, roots are like, this is the square root. Looks like this, right? That would be the square root of x, which is x to the 1/2. Square root, we don't normally put the little 2 right there. We leave that off. But remember, the square root, like the square root of 25, is equal to 5, because 5 times 5 is 25. And so roots, these square roots or roots, are the fractional exponents. So also, for example, if we had x to the 1/3, that means the cube root of x. And so we can see on our notes right here, fractional exponents, when we have x or a to a fraction, that is the root. And whatever that n is, that's where it is there. It's that number of a root. So square root, cube root, fourth root, fifth root, and so forth. Well, we'll come back to the rest of that in a minute. So we also, here's just it written out some more too. So 9 to the 1/2 is the square root of 9, which is 3. Or 8 to the 1/3 is 8 to the, or the third root of 8, which is 2, because 2 times 2 times 2 is 8. Now, also, we might have exponents that are a number with something other than 1 in the numerator. Well, in that case, it's very similar. Remember, this part down here is the root, and then this part up here is the, well, we'll call it the power, the exponent, right? So you can see when we rewrite it, the root is here, and then it's raised to the mth power. We also could write it like this, but this is the preferred way. We're not going to be getting too crazy with these. Actually, we're going to be doing everything in the calculator, so don't worry. But when in the future, when you do simplify, that's the better way of writing it, the root first, because we want to make something small before we make it big again. And so we can see this example right here. So 25 to the 3/2 means the square root of 25, and then all of that raised to the third power. And it does equal 125, because the square root of 25 is 5, and then if we raise that to the third power, we get 125. So we are going to be using our calculators now, yay, calculators, to solve these. And we're going to be using, it moved to the next slide, some common exponent buttons on the calculator are this and this. So if you're, actually for both of them, if we wanted to do this problem right here, we would put in 9 first, we would hit 9. Then we would hit either one of those buttons, either y to the x or that up arrow, that caret. And then we would put in, you might need to use a parenthesis, 3 divided by 2. And in your calculator, it usually will look like that. and then push equals or enter, and you'll get your answer. So you should be able to do that, and the answer is 27. So we're going to make sure everybody knows how to do that, and if you're looking at this because you were absent, don't worry. When you get back to class, I will make sure you know how to use your calculator. So we are going to be simplifying these. We're going to be simplifying them using our calculators, but we're also going to be rewriting each of them in radical form, that is with the square roots. So we're going to rewrite this as the 5th root of x, and that's it. We don't need to simplify it because there's no number to simplify. It's x. This is the 4th root of 16. Now, we're going to be putting this in our calculators, all right? And when you do put that in your calculators, you should get 2 for an answer. This one, we're going to rewrite as the cube root of 27. You can put this in your calculator, and the answer is 3. If you want to pause this and try the rest of these on your own, go for it, and then start it back up and see how we do it. This one, when we rewrite it, it's going to be the 4th root of 16, all to the 3rd power. We're going to put this in our calculator, and let's see, that is going to give us an answer of 8. This one, we are going to rewrite it as the square root of 36 raised to the 3rd power. If we, oh no, 6 to the 3rd power. I didn't bring my calculator with me. So 36 times 6, 216. So you should get 216 for your answer. Don't mind my chicken scratch, because you can do it all in your calculator, so no worries. Finally, this is the cube root of 8 all to the 5th power. So that is going to equal 32 when you put that in your calculator. Okay, and you're going to put that in your calculator for that one. Now, for these, and this is it, for these last ones, we're going to rewrite the expression in exponent form and then simplify if possible. So this one in exponent form would be 32 to the 1/5. Okay, if you use parentheses, it's fine. If you don't use parentheses around the 32, it's fine. This is going to be 64 to the 1/3. Oh, I forgot, we got to simplify. So you should put that in your calculator and get 2. You should put this in your calculator and get 4. This is just going to be x. Oh, this is going to be x to the, put a little 2 there if it helps you. This is going to be to the 3/2. Okay. This next one is going to be 8 to the 7/3. Oh gosh, 2 to the 7, 64, 128. You should get 128. Oh my goodness, I should have brought my calculator. This is going to be 343 to the 4/3. You're going to have to tell me what that one is. I did not bring my calculator in here. But you can put that in your calculator and figure it out. And this last one is going to be 32 to the 3/5. And that is going to be 8. So with this, just know how to go back and forth from root to exponent or exponent to root. And then you can put all of these to simplify. We're just going to put them in our calculator, and you could see you get all really nice answers. I think, oh no, I'm not sure. I'm going to let that go. Okay, good luck.